Okay, and live. So, yes, I think it's a good idea if we all just sort of introduce ourselves first.
Who are you?
First. I'm Nai, and I suppose the biggest sort of part of my background of interest is things related to the mind. So for maybe 10 years or so, very big interest in meditation and Eastern philosophy. And I actually think I never said this to you guys before, but I think part of the reason that I started to study science and the mind from like scientific point of view is probably because of use.
Oh, I didn't know that.
Yeah, I think like subconsciously he's kind of introduced me into the scientific method, I think, and the scientific sort of way of thinking. So now I study psychology, and yes. Okay,
Yeah.
who's next?
That's cool. I wonder, like, just for this rare occasion where we all have intertwined histories, maybe I should say how I met Nai first, and then we can sort of
But who were you first?
how we all tied together.
Who the fuck are you first?
Am I first?
No, who the fuck are you? Before we do the intertwining, right?
You're swearing so much. Oh my god.
Are we not allowed to swear on this?
Are we doing that?
You're demonetized already.
Are we not allowed to swear on this?
Yes.
So me and Nai went to the same secondary school. Nai joined in second year, right? And we had German class together for a few years. Then we knew each other quite well, and like by sixth year we were pretty good friends. But I think we got even closer. So we stayed in, well, yeah, I think when I was in university, or when I was in first or second year of university, we sort of reconnected a bit and became closer friends. And meanwhile, I met Iwan Blake in my undergraduate physics degree. We were in the same class. We got to know each other, and we started going on cycling adventures. That seemed like something Nai would be interested in. So I introduced these two lovely people, and we went on a cycling trip together in 2016. Thank you.
That's it? Oh, shit.
Yeah, and then they hit it off better than I thought they would. I could imagine that they would have hated each other, and they might have done for a little while.
It could have definitely gone that way. Like,
it could have gone either way for quite a while. But I think the combo just works. We tend to balance each other out and sort of share different perspectives, and yeah, it's a really lovely friendship I have.
I'm glad that you brought up the cycling trip thing. Can you hear my chair squeaking?
A little bit.
I can hear it.
Viewers are dropping.
Doesn't bother me.
Damn.
And how about now, Emmet? What's your background of interest, and what are you doing at the moment?
So I went on. So we split ways at the end of fourth year after our physics degree together. I went into the theory side of physics, while Ewan went to the experimental side. And I did a master's in theory in Cambridge, and then that was 1 year. And then I'm now 3 years into a particle physics PhD in the University of Edinburgh. I mean, I'm currently back at my family home in Ireland because of the pandemic, but I'll get back to Edinburgh soon. Yeah, so I at the moment I'm making predictions for the LHC in Switzerland. So that's what I'm doing now.
So what exactly is the LHC? Just for
it's a circular tunnel, 27 kilometers long, and it is used to collide bunches of particles together. And through through these collisions and the products of the collisions, we can learn about nature on a very small scale.
So is that the kind of main thing of the HC, like the main sort of practical utility is just to purely just to learn about small, really small particles?
Yeah, so there's if you think of the spectrum of light as a way to think about distances, the higher the energy, the beam of light, the smaller its wavelength, and the smaller the object that it's sensitive to. So the higher energy you have, the smaller distances you can resolve. So that's why the Large Hadron Collider needs to be so big, because we need huge energies to probe really small distances. And these are the highest energies that humans have been able to reach systematically. And so this is the smallest, the finest grain experiments we can do to probe as far as we can into nature, or probe nature at the smallest scales that we can.
I think that's a waste of time.
I'm just wondering, like, so is it? I mean, I guess you could say that, but no. But like, does anybody have any sort of idea or sort of predictions if there would be any sort of practical utility for this? Like, if we would be able to actually use it for anything, or is it just purely for the purposes of wondering how matter behaves on a really, really small scale?
I think it's a really cool question, and I think nobody knows the practical benefits that will result from it, but I think everyone agrees that practical benefits will result from it. Like, if you think of the invention of the radio, like, that was a huge deal for technology, huge practical benefit. But if you think of also the centuries of thought that had to go into developing the theory of how magnetism and electricity works, the people who developed that theory had no idea that it would eventually result in radios. And that's not what drove them. They wanted to know how nature worked. And as a result, they understood nature in a way such that future generations would be able to build crazy machines that the physicists mightn't even have dreamt of. And there are tons of examples of this, like Einstein's general theory of relativity is crucial for keeping the precision of GPS clocks in sync.
Could you just quickly explain what is Einstein's theory of relativity?
It's a geometric theory which gives us a relationship between the matter content of, let's say, of a region of space and how it deforms this space-time. So previously, if you think of the previous Newtonian theory, there was a sort of fixed, rigid space in which particles moved along trajectories. And if you put something like the sun into this space, there would be a field. It wasn't described the mechanism by which this field would act, but it was just a field that would interact instantaneously with, let's say, a planet that you put into this space as well. And that would give really pretty precise predictions for tracking planets and predicting the motion of stars and comets. but there were a few experimental results which couldn't be explained, especially when things were quite close to the sun, like the orbit of Mercury. So motivated by this and for other reasons, Einstein rethought about what the stage was. So rather than having a rigid three-dimensional space, he had a flexible mollusk-like space, I think is he said. It's a deformable space-time.
Is that like the example, I think, I don't know if this was it that you were talking about before, like if you have a blanket or something like this, and you put a ball on the blanket, that the blanket changes shape? Is this sort of, okay.
Yeah, it's a really good way of thinking about it, visualizing it. Yeah. So yeah, so Einstein did not set out to concoct a really accurate global positioning system, and he probably would have no idea that that was the thing that humanity at large would benefit from his dreamy theories. So I think if you just let people follow this really deep human drive to understand nature, and if you let, I mean, there's a certain type of person who just gets really excited and obsessed about it, and this excitement and obsession will eventually lead to things that have benefit to humanity, in my opinion, I think.
Okay, and that's
what do you think the split is of people? I mean, you think about every physicist we know, you get into it for the magic, right? Well, I don't know. I guess
you time to introduce yourself.
Oh yeah.
Who are you? What are you doing?
Okay. Yeah, my name's Iwan. Went to the same undergraduate as Emmet, and as he said, we both
where was this undergraduate? Just so everybody
Trinity
knows.
College in Dublin.
Oh, very nice.
Oh, very nice, yes. But yeah, or at the end of that, yeah, both of Emmet and I are both very interested in these things, and then it was a little jump across. He jumped into theory, I went into experiment. So I'm finishing up my PhD now in Oxford in experimental particle physics. Yeah, seeing where we're going next. But my point is that when you jump into physics, how many are like, obviously both of us jumped in for like the magic of it and all this stuff. But I don't know, the more I meet, in terms of like, or we knew, Trinity was very nanotechnology based. And there's some people, I think, looking back, they are directly thinking about like that's what excites them, the kind of push of technology and what you can do with it, whatever it be, solar cells, everything like that. But of course, like in my opinion, of course, like everything that's happened, if you think about quantum mechanics or whatever, that's some hocus pocus shit going on at the time. You know, like that's just like some fucking arbitrary, you know, fuck that shit. But you look at like circuits, how they operate now, and like all these fucking like semiconductors and everything in our phone, it all relies on this stuff. But of course, those people working on Schrodinger isn't thinking about fucking satellites and shit.
Well, so why did you start studying physics?
Well, because of the magic, you know. I mean, I don't. In some ways, I had no understanding of how other kids couldn't be, you know, captured by this shit. If you just keep asking questions, you eventually start hitting those like fundamental questions. And I couldn't really get why other kids, you know, were just like, who gives a shit? Or like, you know, why would you want to go see that? You can see it on the internet or whatever. It's like, no, what you want to fucking figure out.
And Emma, do you think that it's the same for you? That like your sort of motivation to start studying physics in the first place was because of the magic rather than the utility?
Oh yeah, absolutely. If it's a choice between those two things, and I think as well for me. So in secondary school, I had a really close friend. We had loads of similar interests. We both enjoyed the same subjects like maths and physics, and we had very similar upbringing, and in terms of the variation between humans, we were a pretty good like control of similar individuals with similar teachers, but there was a difference that we began to notice when we were about 16 in terms of like what really excited us, and it all came down to so for this is quite local, but in the Irish education system in physics, there's a choice between doing an extra module on particle physics and an extra module on applied circuits. And I don't think either one of us could have seen why the other of us found the other option the more interesting or more thrilling. And I think it's ultimately down to maybe how comfortable I am with abstracting a certain idea and then playing on the level of that idea. So if you are at the level of batteries and circuits, you can sort of abstract what's going on inside the battery and abstract what's going on inside the wire, and you can draw a little symbol for a battery and a little symbol for a wire. And then you can develop more and more complicated systems. You can start to develop clocks and systems of logic. You can make a calculator on this sort of this layer, and you can make transistors and more complicated devices, amplifiers, and you can just keep adding and playing and building up boxes and drawing boxes around those boxes and just keep abstracting. And the person who, certain people I think are thrilled by that, playing with a Lego set and then just seeing how far you can push it. And I think that something about that same drive is what makes people thrilled to improve current semiconductors or keep pushing processing power. And I can kind of see that thrill, but I was always stuck at the first step because I wanted to know what was inside the battery and I couldn't let it go. And I cared more about what was happening inside the silicon and than taking it and using it to do things like controlling logic systems. And
as you've gotten older, has this changed at all?
No,
I just also you think we forgot to let you continue fully introducing yourself. Do you want
yeah, sorry, Ewan.
No, it's great. I want to know. Well, let me see this first. I mean, so like in terms of like the fundamental interest. I mean, naturally, I think we were very well, pretty aligned when we were in undergrad. Maybe you were maybe a tad more than I was, but going through, getting older and you start like having to be paid for this shit. Has your opinion on any of this changed at all or been impacted at all?
That's a really good question.
I think it's really easy for me to lose track of the bigger picture. And on the day-to-day and the week-to-week, I have very specific goals that are quite unmagical if I don't try and step back a few years and think about why I got into it in the first place. I think ultimately, if I take a few days even off physics, I'll start to get that feeling of why I started to get into it in the first place. But it is easy to lose track.
Do you ever feel like, because so you kind of started studying physics because you wanted to sort of be able to understand the bigger picture of the universe, let's say. And do you think like doing a PhD and having to specialize in something so specific and particular that you're missing the bigger picture, or do you still get the same, I don't know, amount of satisfaction or amount of magic just by studying one thing, or do you feel like there's anything negative maybe about studying just one specific thing.
Stop me if I'm hogging all the airtime.
I mean, I can answer quickly if you're Emma going to have a longer one, but yeah, I do feel
Yeah.
I do feel that absolutely. I mean, I've thought about it more. I mean, I used to like think, you know, I'd hope everyone would think logically in a scientific manner. You know, think for yourself. Why are you doing this? Why do you like this? Why are you acting the way you're acting? It doesn't have to be too fundamental, but just question things. And then I start going more and more down the line of physics, and then you pick one aspect of physics. I pick neutrinos. Say, if we're going back to the introduction thing, I work in neutrinos and detecting these particles, and there's much we don't know about it.
What's a neutrino?
A neutrino. So I mean, in the staple of what we know now as standard fundamental particles, we've all heard of protons. Well, actually, that's not even a fundamental particle. So the protons and neutrons made up of quarks. So we think quarks are fundamental particles, but electrons. And so basically every time a nucleus, you know, a collection of protons, neutrons will decay, and there's a thing called beta decay. So it shoots out an electron as it decays from a higher energy state to a lower energy state. But every time we found out when an electron decays, accompanying it is this tiny, tiny, tiny mass particle we used to think had no mass, would shoot out as well. And it has no charge, so it doesn't interact hardly at all. And we slowly found out about its existence. And yeah, so trying to understand, first of all, as I said, we thought they were massless. Now we figured they have mass. So what is the mechanism of its mass? And it seems it has, you know, from theory, and it implies that it has a different mechanism of mass. And so this is a fundamental question. Coming back to why it interests you, it's like, wow, this is a fundamental, you know, we go down all these rabbit holes. And I'm sure if you keep asking the questions, you'll come down to the question of what the fuck is mass? Like, what is that? You know?
Oh yeah, I wanted to talk about this later actually, but just I'm just curious.
I'll stick to the point. The initial point is this is something I've been very interested in, and I used to have the opinion that when I was younger, like everyone should think like this, everyone should think like me. But your shit's not more important than any other shit, you know. As you say, like if you want to talk about fundamentals, I think, you know, recently more and more psychology is pretty fucking fundamental. We're all humans here. We're all interacting with each other and understanding why we think. You know, what is, you know, thinking about mass versus thinking about why people think about mass. You know, like those are both similar to me. But the whole point is like your shit smells just like everyone else's. Like what I think is super important.
You're so, you have to be so vulgar. You just can't switch it off for a few hours. No.
The truth won't come out.
But yeah, I see what your point is. Like, I think at least something that the three of us kind of have in common is that we can kind of look at our lives a little bit and say, like, what is the most important thing that I could do with my life, you know, or what is the most important thing that young people should do now to make the world a better place? And maybe it's catching a neutrino, like, maybe in the end it will turn into nuclear fusion. I don't know how that relates to each other, but yeah, something like this to create, say, sustainable energy. That seems pretty important. And also, like, from my point of view, I've been thinking a lot about evil and like just how humans behave with one another. And like, for me, that's also a really important thing to figure out, because I think a lot of the problems that we have, say even, you know, global warming, war, if we could understand what leads a person to have, like, say, low empathy or become, you know, really, what's the word? Yeah, just like really, what's the word when you power crazy?
Normal.
Anyway, I can't remember. And yeah, just like this, you know, the sort of relationship between humans that like just always like continuously inciting conflict. I think if we could understand and resolve that, that's also really important. But then, you know, is playing music any more or less important than any of this stuff? I don't know. But what I wanted to ask you earlier is, you know, like when you said, okay, we discovered that a neutrino exists. How does that happen? Is that through like mathematical formula, or is it through, yeah?
Yeah, well, I mean, for specifically that example, it is like, it's a good question. How do you find something that doesn't interact? And yeah, for that specific example, it just comes down to simple maths, billiard balls. So if you strike two billiard balls together, if it's a two body interaction, if you know the momentum of the particle coming in, since there's only two particles, you can just through a calculation just calculate the exact energy of say the outgoing billiard ball. So when we know that a nucleus decays, there's a fixed energy. It jumps from a high energy, everything wants to lower its energy, so there's a fixed energy change. So then we just say, okay, all that energy should be converted to this electron that's fired out. And then so then they just sat down and they got nucleus together and they had them decaying, and then they'll measure the electron energy coming out. And so you would expect this electron to have 5 units of energy every time. So you should see a spike at 5 energy units. But what you saw was a spread of energies. And so that's just to say there's something that's taking away the energy. Something's taking part of that 5 away. And so from that you say, okay, well, we didn't see anything, so it doesn't interact. And it has to be something very, very small in mass as well. So just from that. And then so that's why the famous was, they call it a neutrino, is an Italian name, little neutral one. They thought it was a neutron, just we know there's some neutral particle. So Eno is small, so little neutral one, a cute little name.
Mm.
And then,
so when you say you do the mathematical calculation, and then you compare it to observations that you make in like the physical world. And so the things that don't match up, you're kind of like, okay, there's obviously something like this that's behaving like this. Let's call it a neutrino.
Yeah, but that's the beauty of, and it comes back again, like, I remember when Emmet and I were splitting these different directions, both of us probably sat down, which one do we find the more important or more special? And I probably had opinions. I actually, fundamentally, I feel like theory is better, and just in terms of satisfaction.
What's the difference, really? Like,
well, this is the thing. I mean, like for that beta decay, the neutrino example. I mean, it's a very simple example. It's just saying energy is converted to kinetic energy of the electron. But that's the theory. We're saying there's an energy and it gets all put into this one particle and it goes firing out. That's the theory. Then you go check it. Are you fucking right? You better be right. And then you go fucking check and say, hey, no, fuck face, you're wrong, bitch. And then you update, the theory. But this is perfect timing. I mean, last week we all tuned in to this G-2. But the point I just wanted to say is that,
can we talk about that?
Let's talk about it. It lines in perfectly. I'm saying, like, you have a theory and your theory's nothing until you check it. But then, what have you got to check if there's no theory as well? So, I mean, to me, one's not more important than the other. They go hand in hand. And to think you're more important is just fucking dog shit. But go on, Emmet. Can you introduce succinctly, maybe more succinctly, what?
Do you just mean specifically between theoretical physics and practical physics?
Yeah, I guess that's what I'm comparing to. But before joining experimental particle physics, I looked more highly, say, upon in my head, growing up. I mean, what we're doing are maths on paper and figuring out things just with a paper and a pencil. And like, that's exciting to me. I love that shit. But having now worked in the field, you can write anything with a paper and a pencil and it's useless until you check it.
And so can you tell us about your time in Canada and what it looks like to actually try to physically find a neutrino and what that experience was like?
Okay, yeah. We'll come back to the G-2, I guess, later.
Okay.
But let's say, the discovery of the neutrino was like decades and decades ago. But, as I said, these things are so like minimally interacting. The example, I guess, is to say, there's such a huge flux of them coming out from the sun. So, all that distance away that they're emitted in all directions from the sun. And I probably have the numbers all wrong, but it doesn't really matter. it's an order of magnitude thing, but it's to say that at any one time you hold your thumbnail up, this tiny area here, there's like 100 billion or some shit flying per second through your thumbnail from the sun, wherever the sun is, flies through your thumbnail, goes down through the earth and comes out through the other side all the time.
And is that because the sun is decaying?
Yeah, there's decays constantly going on. As I said, when they checked it, we had this small sample of decaying nuclei, but that's occurring in the sun all the time. Actually, through fusion as well. I mean, it's not just through decays as well, but neutrinos flying out in all directions, but they're just so weakly interacting that. So the point is, like, I work on an experiment called Snow Plus. It's a kiloton, 1,000 tons of liquid. And basically, you put it 2 kilometers underground because these are so weakly interacting. You have to go 2 kilometers underground in a mine shaft to avoid all the cosmic radiation. And what you see, what we see, something like a couple a day or something like that of these neutrinos. The ones that I said, like 100 billion are going through your thumbnail a second. You have 1,000 tons of water and you only see a couple. So that's it's pretty difficult to measure these things, but and slowly I've become more and more excited about the work put into just doing, checking these theories, and maybe in terms of our brains, Emmet and my brain, like I enjoy getting so far with a theory. I want to get to the point where I can understand it, but I don't want to spend all day on it, and if I can just interact with as many theories as possible, the right ones, then I'm happy camper,
And you said before when you were in Canada, so this lab is 2.5 kilometers underground.
2 kilometers underground in an active mine, so it's a copper mine. And so, but the point is, like, because these are so weakly interacting and so few, you want to have as minimal radiation as possible. And there's radiation everywhere going on right now in your keyboard, whatever it is. So you have to go underground, get dressed in mine shit and get in the cage, and it rumbles down.
You said you had to get naked with your professor,
yeah.
right?
So then you have to like sit there and you queue up
showers.
and you're showering with all the, say your academics you're working with, and you queue up naked to go in the showers. You get rid of all your clothes, you leave them behind, and then you climb into this clean lab and you put on all fresh clothes. That are cleaned every day. Every single minute piece of equipment that goes through that lab is like scrubbed, to a crazy level. But this is the effort you go to. And before I was like, that's some fucking dumb shit, I'll stick to me paper and pencil. But it's the more I think about it, the more kind of gets me going, You can actually access this shit. If you're careful enough and put in the effort, you can actually access these theories and check them. That's cool.
And did you enjoy the experience, or did you find it? Because I would think that being 2.5 or 2 kilometers underground would be super, super claustrophobic. I think I'd have a panic attack or something. Was that like something?
That's what my supervisor asked me on my interview. Like we went through everything, to see if you can join the group, and then at the end he goes, "I hope you're not claustrophobic." And then,
oh Jesus.
Yeah. But no, I guess for some people, I mean, there are, like, I guess I'm not, it's fun. Like, it's a big lab and there's like a lunchroom. And I guess, depending on your mindset, it could be claustrophobic, especially when you're walking through the mine. Like, it is like a dark and dusty, well, it's not dark, but, it's a long, dusty corridor with train tracks going with the carts and stuff like that, bringing all the stuff through. I guess so what is scary sometimes, so sometimes you have blasting, so they're blasting out new cavities, and so every now and then you just hear a rumble. And there was one time underground, you're there 2 kilometers underground, and there's a power outage, so it just goes pitch black, and you hear these sirens going off, and you have to just run to the nearest meeting area, whatever it is, emergency meeting area. And luckily it never happened to me, but my friend was stuck down there for 17-18 hours, so you have to like
my god, that sounds like hell.
Eat rations.
Oh my god, that sounds like fucking hell. Oh shit.
But yeah, you do it for the fun. I mean, that's exciting. I mean, yeah, obviously that sounds like hell, but it's a novel experience to get stuck on the ground, right?
You were saying they've got little kits in the the elevators if they get stuck? Is that?
Oh, the elevators, those are literally just like a bucket. It's a metal bucket. There's nothing else in there. And you're just crammed in there, and it's a double-decker bucket. And you step in, and then the bucket moves down a bit to let people on the second floor, and then it goes rumbling down. But so like I don't mind the claustrophobia, but one thing I was scared of, like it goes at quite a speed, and so sometimes your first few times they give you chewing gum because you have to keep clearing your ears out. You have to keep equalizing the pressure because it's that fast that you're like, if you stop clearing for a second, if you're a little bit congested, you can feel it, and it's like scary, and like sometimes you can burst eardrums or whatever it is. Like,
oh Jesus.
Yeah, I mean, they do say, I mean, they want you to work, but if you have anything like a cold, they'll absolutely say don't go down, like. But yeah, but that's I guess it comes back to the question specifically with physics or particle physics. I mean, the fact a student, like, I shouldn't really be working there, right? We're free labor is the point. The reason I was sent there is that it's free labor, right? You're a PhD student, they send you there, and like, you're there drilling something into the wall going, why the fuck am I drilling this shit into the wall? And it's because like I'm cheaper than or hiring a contractor or whatever it is. And those are the things that make me think. I mean, I joined particle physics for the romantic views, everything I was excited about to tell you, measuring these solar neutrinos, whatever it is. And then you join and you realize you have to get paid for this shit, and you're there watching paint dry on a wall. And you're like, why the fuck am I here? I mean, every subject has its thing you have to slog through, but this is just the reality of the world. You have to be useful in some way.
So do you feel like a little bit of like resentment or something? Because
I can't remember exactly how I felt, but it's just to say, I mean, I enjoy things for life experience. I mean, like, I find that far more valuable. I was underground watching paint dry, whatever, but it just puts into perspective that your shit isn't, I don't know, like, it's hard because it's such a, well, maybe this video is going to damn me later in life, but like, it's such a, you have to ask people who aren't in physics to give you money to do physics, okay? And you have to tell them that your shit's the most important shit in the world. And I guess I don't know how you can say anything's more important than anything else. I mean, like the example, come back to people knowing what they're doing. I mean, splitting the atom, we've talked about this before. Would you join like the Manhattan Project or whatever if you knew? But people who split the atom, they were, I don't believe most of them, say earlier on, say Walton or whatever, that they were doing it for the the purpose of nuclear power, or B, the purpose of a bomb. They were doing it for, the scientific shits and giggles.
Like, I think about that, and I think I asked you a few years ago if knowingly you would join the Manhattan Project and, be part of making this bomb that would later kill a lot of people. And I was thinking about it, but like, I mean, the Germans were kind of making it anyway. And then it's like, if the Americans hadn't have gotten there first, we'd all be fucking speaking German now. I mean, we probably wouldn't even be alive, So, yeah, ethics just seem like a sort of complicated thing when it comes to this sort of stuff. And so, yeah, I maybe no right or wrong answer. But just about the neutrino, is there, for the neutrino, like with the Large Hadron Collider, do people predict what could be a possible practical utility for the neutrino, or is it also just for the purposes of understanding matter at a really fine-grained level?
I guess specifically with the neutrino, it's to me it seems even more like less useful. But I just don't think there's any way, or maybe I'm just not good enough, but there's no way to predict these things, like how useful they'd be. I mean, like the Large Hadron Collider, I mean, there's plenty of uses for that, but you think about what do you call these, the medicine, the firing the beam of particles to get rid of cancer or whatever it is, and MRI machines, and even the internet, right? Wasn't the first like kind of internet setup was just communication in and around the LHC. Like, if I'm trying to fund the LHC, how am I going to predict that they're going to come up with the internet? And you know, you want to talk about the benefits and negative connotations of the internet, we'd be here all day. But I mean,
it's just kind of crazy to look at it in this sort of point of view, like talking to the both of you, and both of you say, okay, we can't predict what the practical utility would be, only that maybe, you know, there is a
no,
practical
I don't think it's maybe. I think it's definite. I mean, obviously
definitely,
not for
yes,
everything,
but
but
like,
it's just there's always. It's
but
just
what
way
I
for
find
everything.
so like baffling is kind of that physics sort of seems to get the most funding out of everything, like even compared to, you know,
You think?
I don't know if this
I
is
have no
correct.
idea. Do you think, Emmett? I feel like
I
theory is like
compared to
so
other
hard.
sciences, I don't really know. No, but
But just think of
in
how
a
much
global
it
scheme, it's
build the
pretty small
fucking
scale.
Large Hadron Collider. Like, how much did that thing cost? It's
Yeah, I get it. Well,
27 kilometers long, and it's a fucking gun. Like, that
It's
shoots.
pretty ridiculous.
Like, how much does that cost?
how much
and it's
was
like-
it, Emmett? Do you know? I don't know. It was
I don't in
It must
the
be in the
billions, but I
bajillions.
don't know the number.
Yeah.
But
Like, to
there's
me,
a,
that seems absolutely crazy. To
I
be
heard a
like,
really
okay, we're gonna-
facetious response to that when someone was saying what a waste of money the LHC was, and you know, I don't like the attitude behind the response, but I think it's a really good point. This scientist replied, "Yeah, if you think of the amount we spend on the Large Hadron Collider, that is a huge amount of money. Think how many stone axes we could have bought with that amount of money." But so it's pretty scathing, but there's a point there.
If you're comparing it to,
space though, that's probably pretty expensive.
or like curing people of, you know, illnesses like cancer, Parkinson's, like they do have funding, but I don't think it really. And maybe I'm just making this up.
Well, no. I mean, it's a good. I never actually thought of comparing it, but I wonder. Just say, let's say, cancer research, because the whole point is that these particle things, it's one collection of universities, all with one experiment, and obviously that one experiment is so fucking expensive. But I feel like you should compare it to the sum of funding for cancer research across a whole country or the world, right? So I don't know is the point, but yeah, I thought physics is like not good funding, you know, like, I mean, so you know more than I, but like theory, you know, as I said, both these things are equally important, but I feel like, you know, theory isn't expensive to fund and you know, students are struggling everywhere to get a place, you know, but you can speak more to that. And like,
it is hard to justify in one sense, but then if you think of going back to the internet is a great example. If I was an entrepreneur and you know I wanted to launch a whole new sector of the economy or a whole sector of human social lives, you know, it's just so impossibly unlikely that I would sit there and I think, what if we all had this integrated way of sending information to each other, sending large amounts of information to each other, have this global system. And let's say I was still this entrepreneur who only cared about profit or about being a guy who came up with a new technology. He's not going to go then to university, learn about circuitry, electronics, learn about all this infrastructure. It's just not going to happen with that motivation. But if you have, let's say I'm a nerd here in Ireland or Scotland, and I have a nerd friend in France, and we want to communicate ideas, and we find that we really want to get to the bottom of some unexplained mystery. That's the type of thing that can give people like almost, I don't want to say inhuman because it's a really human drive, just a obsession. And if you get two people that are obsessed about this to the extent where they'll do anything to, you know, get a slightly more information transferred to each other or able to talk to more colleagues about this idea that they're so passionate about, then they just start spawning this technology, such as the internet, to send huge amounts of files to each other almost instantaneously. So there's the question of what would be the best thing to do, or what's a good thing to do for humanity, and then there's what's a thing that you're super passionate about that might have benefits, or or what's the thing that you're super passionate about that won't cause a lot of harm? And when I think about it to myself, I don't know if I'm just trying to morally justify the fact that what I'm doing is of no benefit to anybody. But if I was to decide to do something that I thought would be to the betterment of humanity, I'd be doing it out of a feeling perhaps of obligation, or just this feeling that I should be doing this because it's good. And I don't think that's really what drives us forward. I think what drives us forward is us following what we're really passionate about. And if you're the type of person that's really passionate about saving lives and you go into medicine, that's great. But I don't know what I can do with my passion that would directly benefit people, but I'm super passionate about the standard model particle physics, and I don't think that's doing direct harm. So I just think I was born to be this ant in the big ant hive, and I think, you know, I'm all right at doing this. I'll do this little job and just do it to the best of my ability, and then you can still feel as if you're part of something bigger. This hive of thousands of people working, developing these theories and testing them.
Well, I think that's like part of the reason that life is so colorful, because everybody does different things and everybody is sort of born to do different things. Like, I think it would be really wrong to, say to somebody like, oh, you shouldn't do this, you should do something that's directly helping people because I do something that's directly helping people. It's like, okay, fuck off, you know what I mean? Or even if people really have just, people just want to play music, or people just want to, I don't know, paint pictures or something that's just, pretty neutral. What makes life colorful is the fact that everybody's, doing different things.
They're all on different time scales, right? I mean, the comparison of saving lives, that's like, I can save lives now. But the physics thing, I do fully believe like all fundamental physics is useful, just not right now. It will be later. When you want to get the the next solar system, there might be some, you take advantage of some fifth force, G-2.
Okay, can we talk about that now?
Yeah. Wait. I want to talk about it, but I was just like, in terms of like advancement, I mean, as you said, you can think about, I want to be useful to the world. I guess I never really think about being useful to the world. If I can do, as you said, I like the thing that you just do what you're passionate about, and it'll probably pay off somewhere, unless you're passionate about like murdering women.
Yeah, well, some people are passionate about putting people in concentration camps, and wiping out particular.
You're wrong, then, Emmet. Yeah,
I'm wrong. Yeah, I know. Yeah.
That's a fair point.
Just, I guess it makes life colorful.
No, but but the thing about like
a bit too colorful.
Yeah, but the advancement thing, I mean, like, you want to make it better. I don't know. It's just like, how far are we? I guess there's no stopping us now, right? Shit's moving crazy quick right now, right? I mean, we can just feel it.
I feel like we're sort of in a race against time. I don't know how you guys feel about this, but I've kind of gone in the habit of reading the news every day and just like fucking punishing myself with the suffering that's going on all around the world. I seriously am losing sleep just from reading the news, because it's always like, oh, impending war, this country's doing this. There's, how many people died from the military thing in Myanmar today? Global warming is happening at a much faster rate than previously expected, and it's just like every day I read the news and I just think, oh, this is it, like, really, we're
is this new shit, or is it the way that the news is sent out and it's so much more accessible? I don't know. I mean, was it always this crazy? And just obviously it's particularly crazy right now.
It's like global warming is a thing, and it is happening really, really quick, much quicker than I think most people are aware of. That's what like keeps like coming up in these sort of articles. It's like scientists are really trying to raise people's awareness just about how quick it's happening. If you just think about how much plastic we use, how much coal we burn, all of this stuff, and how many people we are, it sort of makes sense but just like also in terms of conflict and war and the getting closer every day to the big superpowers coming into direct conflict with each other. I kind of have a pretty pessimistic view about this. I don't think we're going to last another 1,000 years, you know? Or if we do, it will be a really small percentage of us.
But the advancement is so, I don't know. So I just saw, do you see that monkey Neuralink shit?
Oh yeah, yeah.
That shit. Well, I mean, it's just like, it's fun to describe. So basically there's a monkey, a macaque or something, and they've apparently put the Neuralink chip in the monkey's head, like in the head, you know. I guess, you know, the technology, it's all right, I'll set it. So then the monkey's there and it's playing a game. So it has a joystick and then it has a tube directly going into its mouth with banana smoothie that comes out. And so it moves the joystick to move the dot into the square that a square will randomly, and it controls it and it puts in the dot. And then so they calibrate. It's such a funny, like, this is madness. You got a fucking monkey with a tube, like, and then you can, you know, correlate it with, you know, a gamer right now, a gamer kid with Doritos or whatever, just sitting back playing a game. But
yeah, just so
direct
for
feeding
people
into
who
them.
don't know what Neuralink is, it's a Elon Musk's project. It's like a brain computer interface. So it's essentially this tiny coin-sized chip that you replace a part of your skull with, and it basically has thousands of electrodes which both take data and send electrical signals into your brain. So it's basically able to take the signals and decode them so that you're able to just, well, with the monkey, right, he was just able to control the thing on the screen without actually touching it anymore.
First they do it with the joystick and he moves,
Yeah.
and then they calibrate from that data, like, oh, he moves his hand, and then so from those brain waves, then they do it again, but they disconnect the joystick. And just from,
I thought that was so cute that he was just using the joystick and he thought he was still using
but
it.
is this so, like, I guess in terms of actual technology, maybe it's not that advanced, you know, it's just like reading the signals and calibrating. And but I guess I wasn't aware that you could do this. You're allowed to just get a monkey, open his head up. And so I don't know if this is that video real. Like, I don't even know anymore.
Yeah.
I mean, it was on it was on a
follow
YouTube channel called Neuralink, and there's all other shit. I need to double check, you know, that's all. But it looked pretty fucking, it's pretty hard to fake.
Yeah, I've been following.
You're allowed to do that. You're allowed to get a monkey, open its head up, and do all this shit. I didn't know that. Madness.
Yeah, but like something like Neuralink, I mean, it has a you know, a very obvious potentially beneficial things that it can do, because
potential. Potentially
Huh?
beneficial. I think it's so mad that we're going so fast. Like, it's so hard to keep track. I mean, I think of on small scales, like I don't know, for an example, I don't want to get too deep into it, but just, you know, everything we're trying to do, force people to do, is like with good intentions, you know. For example, and obviously it's a contentious subject, but I mean, you know, representation in universities. So you kind of not everyone does quotas, but you try and equal out the balance and have like, that's a well-meaning, let's do this, we want to
what
do
are
it
you
for
talking
good.
about?
So for example, you know, there's say too many, you know, white people in universities, so you want more minorities, and so you trying to encourage them to go come in, even if they have, say, lower, they come from a harder background, so they might not get as good results or whatever. I mean, so, you know, there's a specific example, but I'm just saying the well-meaning intention is that we get more minorities in. And then my point is like, it's real short term, you think it's good, but what are the long-term effects of telling a kid that it's their race or the color of their skin matters, or like it plays a role? Of course it does. I'm just saying, like, have you thought out all of the consequences? So I mean, Neuralink sounds great. I just don't, what's the consequences of it? You haven't thought of everything, have you? There's no way.
Well, I mean, like, if you look at it, okay, it sounds fantastic because it's able, you know, well, hopefully we'll be able to offer people with a spinal cord, you know, problems or injuries, like, you know, neurological problems from stroke or Parkinson's disease, it'll be able to help those and improve those people's lives. But I think Elon Musk is also going more for like everybody should have one as like a cognitive enhancer, because as we get older, our memories start to, you know, decline, or, you know, just, yeah, cognitive, you know, power in general. And then, but the fact that it's really able, it's like a device that's really able to take data from your brain and send signals to your brain seems really dangerous. And it is dangerous. If it was possible for somebody to potentially hack into that, I mean, they would be theoretically able to choose which signals to send to your brain. But, you know, his point is that they've built it from the ground up with the security, so they kind of, you know, this the security sort of implemented into the whole design of the thing, so it should be, you know, basically impossible to hack. But I don't know if I even trust Elon Musk with my brain data. You know, it just,
I mean,
it just
there's no way he could guarantee the safety. I don't know how you could for the future. There's no fucking way. There's no way you can say that.
yeah.
But I mean, it's just I do like in part of his argument, it's just like we're already. I mean, the only difference is you have the chip, but it's right there, and you pick it up from your pocket to your eye. You know, it's just one extra step. You know, it's just like here, you know. But I mean, there's no way to predict the fucking. But that's the whole point. We advance, we see like whatever. That's the whole. So then some people are like, well, fucking slow down, stop. You know, let's just stop it right here. You know, let's go back to farming.
And just back to the point of representation in universities and all of this kind of stuff. Yeah, what do you think about it?
No, I don't know. I don't want to be.
No, you don't want to do that.
No, I mean, yeah, I guess I don't know. I mean, I feel like that's even like a not great example. I mean, that's something that is important. I mean, if you know, there's areas that just don't get as good marks because they're, you know, poor. You know, you want to do something like that. I'm always afraid. I guess maybe I'm biased in a general sense, as you know, both of us now. I mean, I'm not fucking. I don't want to be part of a group like, oh, you're Asian, you're white.
Yeah.
You're like, what are you talking about? My name's Ewan.
Yeah.
You know, like I don't fucking care. You know.
Yeah.
So
I
guess
love
I'm
the
just
way,
sensitive
like,
to that.
or rather, I don't love the way, but in the sort of sarcastic sense, is like they try to decrease the importance of the whole race thing by amplifying it. You know, they're like, oh, we need to make everybody equal, so we have to really think about race. You know, it's
No,
like,
I wasn't
never
aware of people's races until it was made a big
yeah,
deal. I just look at a
yeah.
person, and obviously there's subliminal shit that you're not aware of, and of course, you know, you gotta fix that. I just don't like it. Like this is a black woman. This is an Asian woman. It's like I don't know. I just saw a person there, and then now I read the word. Oh fuck! You fucking ruined my train of thought there. You know.
Yeah. I agree, because I think like I never really thought about race as much as I do now, because I realize people are so fucking sensitive about it, that is like, oh, you have to think about it. Whereas before, I probably wouldn't have really noticed if somebody had a slightly different skin color. And even as somebody who experienced a lot of racism in like primary school, and even a little bit like jokingly in secondary school, I mean, it was not such a huge problem. It's like, okay, you know, some Irish kids are not used to seeing somebody who's a little bit different, so they, you know, teased me a little when I was a kid. Who the fuck cares? You know what I mean? Who cares? Like, I mean, if it really is the case of people being discriminated against in the workplace or in universities, obviously I think that's absolutely horrible, and people should like avoid doing that at all costs. But yeah, I really don't agree with the level of sensitivity.
No, but it is a different situation. Like, I mean, we're supposed to be talking about America, right? I mean, clearly it's a thing there. And so this is the way to treat it. I'm just and maybe it is the best way. I just feel like it's a step behind where I want to be, you know? I don't want to be sucked into that. I wasn't thinking about it until, like, I feel like we'll fix it, and then we'll eventually get to the stage where the whole point is not to care about race. There'll be more motherfuckers that look like you and me. Like, where the fuck are you from? You look weird. You know, like ethnically ambiguous motherfuckers. I mean, that's the end goal I'd have assumed, but But
the
it's a different
biggest
situation
thing,
there.
the biggest sort of qualm and this is like super controversial, but not for me. Like America, for me, looking over from here over at America, and it definitely seems that they're taking things to the extreme over there. And one particular thing, I was listening to a podcast with this doctor, like PhD doctor. She's a neuroscientist, and she specifically studied the differences between male and female brains. And, you know, there are clear differences between the male and the female brain, right? But this whole kind of concept that, oh no, that's an illusion, that's just a social construct, gender doesn't really exist in the biological sense. There's a male and female, or constructs, and gender is on a continuum, and we have to agree with everybody who says, oh, today I feel more like a man, or tomorrow I think I'll be more female. But that's fine. I really couldn't give a fuck about how people want to live their life, and if they want to feel like, you know, a male one day or a female the next day. But the thing I think is that is becoming super, super problematic about this is if a child, like a young child, goes to a psychologist and they say, I'm a little girl, but I feel like a little boy. The psychologist, this is what this doctor was saying in her podcast, isn't really allowed to do any further investigation. Like, they're not allowed to say, okay, is there any other reason that this child could be feeling like this? Could they be suffering from some sort of psychosis or some sort of other delusions? And they can lose their license for not affirming the child. And now sex changes are like the US government is investing money into making sex changes possible for kids. You know, that's child abuse, if you ask me, you know?
You had
I
some
just think
experience with this, right, now? What was it like? You felt like a little boy at some stage, right?
Yeah, like, I mean, for me as a kid, I was a tomboy. I used to love fighting. I was just purely probably because I had, you know, a stronger influence from my brothers, and let's say so. I was enjoyed fighting, playing football, playing all of like the violent boy games, and just like, you know, I remember like playing football outside my house, and it was like a hot day, and all the boys were like taking off their shirts, and I was like about to take off my top, and my brother's like, "What the fuck are you doing?" You know, I was like, I mean, if I had to go on to a psychiatrist or anything, like wearing boys' clothes and stuff, and like maybe they'd notice that I was sort of, what's the word? Like, enjoyed male typical activities. They imagine like they being in the kind of environment that we are today and being told like, oh yeah, you're probably like transgender, and being given a sex change as a child, my life would be destroyed, you know? And I'm just so terrified for all of like the little kids that are going to be in situations like that. They're going to wake up when they're 25 and be like, why am I a boy when I was born a girl, or vice versa, you know?
But it's probably beneficial to another group. I just don't know the numbers, right? In terms of
Oh yeah, for sure. I think people who actually are transgender, because transgender is an actual phenomenon. Like, you know, they looked at the brains of transgender people, and they saw, for example, if you were physically a male but felt like a female, like a real transgender person, actually your brain is closer to a female than it is to a male. So there is an actual phenomenon happening there. But, you know, the fact that we have, like, the fact that we're under so much pressure to affirm people without doing any sort of further investigation at all, because people are just so sensitive because it's a political topic. I mean, that's terrible, you know, from my
it's a
point of
dodgy
view.
subject. But I guess in terms of our conversation, it does come back to short-term solutions, and that's, you know, potentially with long-term problems. But maybe it's a long-term good. I just don't. I don't know what the data is on that. Like,
Yeah,
how
I guess
beneficial is
we'll find out.
it? We'll find out. We'll find out. Just like these vaccines, huh?
So Emmet, you're very quiet. Do you care to tell us about this fifth fundamental force of nature.
Yeah, what's happened to us recently, huh? We're jumping all over the place, huh?
Yeah, I mean, I think in terms of experiments, I think G-2, or the anomalous magnetic moment, is such a neat way to describe the whole workflow, the whole methodology that Iwan was talking about the interaction of experiment and theory, and it's got such a long history as well. Like, it goes back to classical mechanics, and I like to think of if aliens came to visit us or were observing us, and they wanted to know at a quick glance, how far has this Earth, how are these humans doing? I would just maybe go on Earth Wikipedia and say, oh, they know the anomalous magnetic moment to this many decimal places, and about, like, if I wanted to do a quick check on a species, I'd see, now, how many decimal places do they know the anomalous magnetic moment to? It's just such a.
And how many is it, Emmet?
11. I could be insulting decades of work if I get that number wrong by one. But I think 11.
It's like 4 PhD students you just ignored there.
Yeah. We can go back to.
I guess what is the G-2?
Yeah. Wait, first of all, so from my very brief understanding from reading a BBC article, it's a fifth fundamental force.
I'd like to come back to the.
But what are the other four?
This comes back to our thing of how you sell it. I mean, the hardest thing to sell sometimes is physics, because it's so far away, the benefits. But the point is, you come up with these taglines, and I didn't think the tagline for this one. Now looking back, I should have come up with it, but they picked a pretty fucking nifty one, I guess.
Yeah, like I was surprised. Like, I was following the live announcements, and I was, I've been excited to hear this for years. This latest result.
Emmet told us, like, oh, this is happening way in advance, and I totally didn't realize.
So I've been buzzing about it. I've been thinking about it, and then I see the headlines. Could this be a fifth fundamental force? And I just never heard it in those terms before. And there's a way in which that's a good description of it, but we can.
We'll come back to it.
Let's get it.
We'll first say, come back to the theory and experiment. So the point is, like, we have this standard model is like great. It's this fucking amazing, seemingly, we know there's problems with it, but there's seemingly so hard to break theory. And what it's based on is on symmetries and, like, these things that, are so, you don't have an intuition for from everyday life, but it somehow describes these particles to such crazy precision. So the way to check is essentially say, Emmet can go into more detail, but it's just to say the way to check is, and it's the ultimate test of theory and experiment, it's just, let's say there's an interaction and you can measure something about this interaction. So what does theory say about this interaction? And what does experiment say about this simple, like, two things coming together and interacting? But the point is that it gets very complicated. If you want to reach all those decimal places, you add so much more, like chaos.
You're losing me with the decimal places.
No, but that's just to say, if you measure an interaction, two balls hitting against each other, you can do it very approximately with just energy 1 and energy 2 coming in. And it's just to say, let's check it again. Let's add another. Is it 1.01? Or what if the ball, like, bounces a little bit, and we take, so instead of, say, two balls hitting each other, you're adding, say, I don't know, friction. You're just adding more and more to the picture of what could possibly happen when two things interact. Zoomed out, it's just A and B come together, but it's just how much can you add to that A and B picture with the theory, and how accurately you can measure an experiment, and then you can check them. What's the number the theory says, and what's the number that experiment reads?
But I'm still not really clear about what this discovery was.
Yeah, so okay. If we go back to maybe the electron magnetic moment. So so if you were a classical physicist, let's say you were a Victorian physicist, and you were thinking about, okay, you've got a ball of charge and it's spinning around, and you thought of an electron, just like a billiard ball that had this charge and it spun around. I guess what's being measured here is how much that spinning ball of charge acts like a bar magnet. So what is its magnetic moment? It's the technical term for it. And if you were there with your big mutton chops and working by candlelight, you'd go, aha, this number is 1 in my units that I'm using here. It's 1. And then maybe someone would go to their old school lab and they'd measure it and they'd say, no, I just measured it and it's 2 of these units. So there's this factor of 2 that's a puzzle. And then when we get to the 1920s, so now special relativity has been developed and quantum mechanics is taking off, and people are trying to think about how can we combine those 2 things. And we just skip past that whole story. In Dirac's attempt to come up with a theory that combined the quantum and relativistic description of an electron, among many cool things that his thinking led to, his Dirac equation came out with a prediction that it's exactly 2. So this is like a huge triumph. Before the 20th century, we were off by a whole factor of 2. And then we learn lessons from special relativity about space and time. We learn about how quantum mechanics work. And when we merge those 2 ideas, now we get bang on, spot on 2. But then, I'm not sure what the historical order of this happens, but I guess it doesn't matter. This is just an illustration. Let's say your experimentalist from the 20s or 30s comes along and says, yeah, but we're finding it's not actually 2. It's 2.001, or I should really know that number. But there's a discrepancy again. And what is happening is that these are not discrete particles. What they are fields. So we don't have electrons, we have a field.
By discrete particles, do you mean like separate from each other?
Yeah, they're not like, there's a way in which they're like billiard balls, but they're ultimately not like small billiard balls. I don't know why I say billiard balls. I think it's because I've heard that
billiard
so many
balls
times
3 times today.
Pool balls.
Billiard balls.
I don't know why I'm not calling them pool balls. I've never played billiards. So there's a way in which they're not hard lumps, and a more useful and a more accurate
with
way.
hard lumps now.
I don't know.
Billiard balls.
Okay.
They're like, okay, it's more useful, it's more accurate way to describe them is by saying there is an electron field everywhere, all here, and if I excite it, if I jiggle it enough, I will make an excitation in that field, and that's what we can think of as an electron.
So, okay, just to see if I have this correct. Before, they thought that electrons were discrete units that I'd say were separate from each other. And then there was a discovery to say that it's more of a field, and an electron is more an area of excitation. Rather than.
So it seems to us that there's it seems at the resolution which we can detect, it still seems like it's a single point that this field is excited at. But it's sort of the developments of the 20th century were seeing, okay, what happens if we actually think of these as fields, and that we just observe the ultimate point particles, but they interact via fields or as fields. So if you think of, let's just say our universe has 2 ingredients, an electron field and a photon field, or a field of light. So now that the excitations in a photon field would be like light coming from the sun or from a light bulb. And these two fields are not, they don't move separately, but they interact with each other. So if I take the electron field, it can cause an excitation in the photon field, and vice versa. The photon field can interact with the electron field. So,
and is that true? Or is this just an example?
This is I mean, it's true as in, like, we derive this from observation. We know things with charge will interact with things light. So electromagnetic, we usually think separately of electric fields. We know electrons will accelerate in electron fields, or say curve in a magnetic field. Well, its origin is an original or a single force, the electromagnetic field. But that's to say that from years and years of study, we can model these interactions such that you treat an electron as a field that expands everywhere, but you can think of it localized sometimes with an excitation in the field somewhere.
And is this quantum mechanics?
So this is now quantum field theory, or which is
okay.
So quantum field theory is the marriage of quantum mechanics and working in a world compatible with Einstein's special theory of relativity. So we've got, if you try and merge those two theories together with one or two other physically motivated conditions, what you ultimately get is a quantum field theory. Now, when you ask that, is it true? I think that's who am I to say it's true? But what we can say is that it is the most fundamental layer that we have unlocked. It's stunningly accurate at the energies which we can currently measure things. So
stunningly accurate. Like, that's the whole point. If you want to measure what is something true, I've stopped thinking about that. It's mainly how well does it work, how well does it predict. And if you want fucking to pick something to like, oh, this is pretty fucking good, this is the one.
Actually, Ewan, while I rant on a little bit, could you actually get the numbers, the experimental and
sure, yeah,
theoretical?
Yeah,
okay, so
we've gone off track.
Discovery?
Yeah.
What is this muon thing?
Okay, so all I wanted to say was you can you can get a electron field and a photon field, and they can interact and make a new electron ripple. But that's not the only way they can interact. So you could take an electron and a photon, and they could maybe interact and do a little dance and then go on to their final end product. And they can interact and share and have maybe 3 or 4 intermediate exchanges with these fields before they result in a single electron that's measured. So there's this whole infinitely complicated dance of how these fields can interact to get you to the same endpoint. And what we need to do is sum over all of those possibilities. So we need to account for all the infinite ways which they can interact. But each time the field interacts with another field, there's a cost to that. There's a likelihood which that will happen, and the likelihood that they will interact 5 times along their journey is much less likely than if they were to just interact the single time. So each time, imagine like this dance between 2 partners, and each time they change partners with maybe a passerby, and as they keep dancing and swinging, the more interactions that happen along that journey, the less likely that path will be. So what we can do is
less
just
likely.
The more interactions there are, the less likely that particular path will happen. And
I'm trying to think. So maybe I haven't thought of it fully yet, but if you got like a big square, let's say you're in Moscow Square, for some reason it was full of people, it's just saying you, like, say, walking from one end of the square to the other, and you're just walking through a crowd of completely random people. And those people are sampled from all over the world, right? So what's the probability of you say walking through and meeting someone you know is a certain low probability, okay? You know, if I walk through once, maybe one time in my straight line path, I'd meet a family member, you know? But then what's the probability of you walking through and meeting all of your family members in that one journey? It's those small probabilities multiplied by each other. So it's to say, as you said, there's some probability that, say, it interacts once, these waves. And so every time you add another meeting or an interaction, it just gets less and less probable. Just like, you know, if you're sampling from all over the world, it would take, yeah, in that one journey that you did it in, like, I'm not going to see my mom, my dad, and my brother, you know, probably.
Okay.
But it can happen. Yeah.
So if we get back to our story, and I've taken us a bit too far off track, but let's say we in hindsight, with all of that interaction story, in hindsight, what Dirac was actually computing was the single interaction story, and that gave us the exact value of 2. And then so another 20, 30 years of theoretical development, Julian Schwinger first did the calculation of what happens if there's a single additional interaction, and that led to a theoretical prediction that was let's say a 1% correction to this exact value of 2.
And drive that home. I mean,
no, but that drive, are sort of,
drive that home. So like the single interaction is gives you 2. What we see is that, you know, it's not exactly 2. And it took this motherfucker, and I forgot his name already, Schwinger, how long? 20 years to add that extra. Because every time
let me get the numbers. The numbers are cool.
Yeah, I'll get it. I have it here now. But I mean, every time you want to add another interaction, it's a lot of work. Okay. You have to calculate all this. And so by adding that second correction, wait, Emmet, I got this here, if this is what you're looking for, right?
Yeah, there's the picture of the single additional interaction there.
Like I can't put my hand over the screen.
Okay, I feel this is very
no. We can break this down. So
okay.
Or Emmet, you do.
Okay, yeah. See where your finger is there. That's an electron coming in. And what it could have done is just interacted with the photon on the right-hand side.
So the photon is the wiggle, and the lines with
wiggle.
arrows are the electrons, say.
Okay.
Yeah, so it could have, there's a simpler vertex that you could have drawn, which is just the black arrow coming in, hitting off the photon wiggle.
Let's do it. So we're saying electron, okay, and it could have just interacted. Maybe this is a wrong. You're not supposed to do a 3-point whatever. But this is your photon is the wiggle. The electron is coming in, and then it scatters. So it changes the trajectory, right, Nai? You're okay with that?
Okay.
Yeah. So that's to say, go on, Emmet. You can annotate too.
Oh, can I? Oh, cool. Yeah. So so if that was, let's say you were trying to calculate the magnetic moment there, you would get a value that was exactly equal to 2. But if you then come along and say, well, what happens if instead of coming along this way, what if I shot out a first photon, then we interact with the original photon here and reabsorb that original photon. That's a thing that can happen, and it's a thing that you will start with the same start point and end points, but this is just another way for that interaction to occur. So it does happen, and you need to find out what the probability of this to happen is. And it turns out that this is, 0.00. It's a 0.001 less as likely to happen as the first drawing we did. It's much rarer.
Like not treating me like an idiot. It's saying like I'm walking down the street and I find a fiver on the ground. That's low probability. Then I walk along the street and I find a fiver, and then right after that I find another fiver. Like that's a low. It can happen, but it's a too low.
Yeah, I understand. Okay, so a decreasing probability with every interaction.
Yeah.
Yeah. yeah, so it took maybe from 28 to 40. So it took 20 years to go from 2 to 2.001. That took 20 years of human effort on the theory side. And likewise, experimentalists were having to measure it more and more precisely. But what you can do is you can keep adding different stories to how this happened. Like this could happen over here. It's less likely than the thing that's there in black. It's a lot less likely, but that's a way that those fields can interact, and we need to account for that, and we need to add that correction to our original result. And that might give you these numbers. I don't know, but each time you add another, we could have this, and maybe that would, if you did all these calculations, and they're crazy calculations, but if you keep pushing it, you keep pushing your theoretical prediction for what this measured value should be.
It's nearly like a big dick contest. How many decimal places can you go?
Okay, but I'm still not understanding what is a muon and why is this new discovery so exciting?
Okay,
And why
we're still on an electron, but it is just to say a charged particle, anything with charge, will interact with light, electromagnetic fields. Okay, and it's just to show, like, we have this theory. And you can push it. You can keep pushing and testing it. Like, all right, well, let's push it even further. And every time you check it, it matches the experiment. Okay, and this crazy levels. If you look at all the numbers here, I mean, you think about measuring like a stick. Oh, it's like 12 feet or 121 centimeters, maybe 121 and a half. This number is crazy, and and every time we check, it matches the theory. So this is with an electron, okay? And in our theory, when anything with charge interacts with say light, it's the same interaction no matter what the particle is, okay? So we know there's an electron, and then there's this other family of in the same family but another type called a muon, and then there's another one called a tau. And the point is that they have the exact same charge, and we expect them to have the exact same interactions. It's just that they're heavier. So the muon's 200 times heavier than the electron, okay? But all the interactions are expected to be the same. So we did this big dick contest comparing theory and experiment to this crazy level, okay? This is the electron anomalous magnetic moments. It's a way of checking theory and experiment. Crazy match. Now, Emmet, you just go.
Do you want me to stop sharing the screen, or do you tell me?
Sorry. Yeah, that's a good show. But then it's just the point, like, okay, let's check if these are literally the same particle, but just one's heavier. Or that's a question. Why is it 200 times heavier? Let's do it again. Let's do this contest again, this comparison. And they just did it. They did it 20 years ago, and now they did it again. Well, at least theory's always like trying to update the numbers, but experiment.
So is it just kind of like going sort of back to what you were saying earlier about the relationship between theoretical physics and particle physics? So the theory is like mathematically seeing how matter is behaving on a really, really small scale level, and this was just an experiment to test the sort of newest theory, and basically they found that it was super, super accurate.
Yeah, well, we're always trying to test it, right? We're always trying to break the theory. Like, we know it's not the complete picture. I mean, or else we want this, eventually want this unified grand theory. There's one theory that'll explain everything. But we know there's gaps.
Oh, speaking of which.
No way, we're going to get fucked. Let's stick on it, But just so we're trying to test it and break it everywhere. Okay, so we did it with the electron, and it was amazing. Like, whoa, this theory is amazing. We can't break it. Then they did it with the muon. And what happened, Emmet?
So okay, in 2004, after I think it was 2004. That was the up until yesterday or the day before, that was the most accurately this quantity had been measured, and at the time, the physical community, the theoretical physics community, came to a consensus on a number for what they think. This is what the standard model says this number should be if we measure it. and there's a difference between those numbers. Now, finally, a small but significant difference was observed. But then we need to, go back to really what one of the core elements of physics, and like the thing you learn on day one, is that numbers are meaningless by themselves, like in terms of making a prediction, if you don't also give an error bar for how likely you think the result will deviate within that bound. So if I am to measure myself and I say, oh, I'm 180 centimeters, and if I don't tell you the precision to which I measured that, you've got no idea how accurate that statement is. If I told you I used a piece of string, and then I measured this distance, I figured out how many of my thumb to pinky distances I was, I might say I'm 180 centimeters plus or minus 5 centimeters. And if I tell you that error bound, you've got a feeling for how accurately I know my number. And let's say I'm the theorist and the expressist. I'm doing my pen and paper calculations or doing my number crunching. If I say to Iwan, hey, I think the anomalous muon moment is 2.0001, just to make a number. If I give him bands, that number is meaningless. But if I say, if I try to account for everything that could go wrong in my calculation, and I'm not talking about making or writing a 7 as a 9. I'm talking about, can we get some estimate for the terms I'm neglecting or any approximations that I know that I'm making? And can I come up with a number to say, this is, my number is here, but it's quite likely that it lies somewhere in these bands. That's a useful number. That's a useful quantity then to compare with Iwan, say. And meanwhile, he'll be.
Did we lose him?
Oh shit, I thought that was just me. Here we go.
Lost you for a minute.
Yeah. Oh, that was strange. Where
no,
we
didn't
just about to
too
compare,
much.
right?
The number,
Error.
useful number. This is
Useful number. Okay.
Yeah.
My number's here. Okay.
Right.
And then I'll ask Iwan, and we'll be. He'll say, oh, this is my number lies in here, but within here, and then we'll say, oh, look, there's a chance that our two numbers are different numbers. Now, depending on the overlap of our error bands, we'll get excited or not if that's a significant difference. If I say I'm 60% sure.
Yeah.
Yeah, there we are. This is, hot off the press. And in green is the current consensus of the theoretical community. And on the right-hand side, the red line there is the brand new result. Blue was
20 years ago. The first one, 20 years.
Yeah.
And like, it's so hard with these things. Like, it's just a bar. But like, you think of the hundreds and hundreds of toiling, like crying fucking theoretical students there to come up with this number. And then the hundreds and hundreds of crying. This is 20 years ago, 20 years later. And the whole point was that the data for this experimental result was taken in 2018. And it took that 2 years just to analyze it and make sure that every single thing, just to come up with these error bars. Like, the actual result is the easy part. The hard part is coming up with these error bars. And then finally placing on the graph, and you can see that their error bars don't overlap. There's some separation. And that you've some disagreement. And this is the point, is to say that we have this theory that's so fucking accurate everywhere, but clearly we're missing something, because these should overlap. the red, or the purple, the combined result, and the green theory, but they don't.
Okay.
So this is so we just know that there's something's missing. Okay, there's something wrong with the theory, and so then
Okay.
Let's
let's take it down a notch, because I have to admit my concentration is sort of suffering and I feel stupid now.
No.
What? Well, you got to keep us in check now. This is the point. We
Yeah.
can go on.
Yeah, it's interesting, but I feel like a really stupid person right now for
That's our
Well, maybe we
fault.
could talk about the
that
consequences.
Fermilab, that's the laboratory named after that Italian guy who basically created the hydrogen bomb, or was it the atomic bomb?
Fermi.
Fermi's involvement, I don't know what his exact involvement was in the war.
That's not how I thought of him.
Oh, I thought it was, wait, he was an Italian guy, right?
He was, yeah.
I think he basically started the project.
Damn, bro.
Yeah, anyway, maybe not.
He did the neutrino, no? Oh, wait. Was it? Oh, fuck. He has been called the architect of the nuclear age and the architect of the atomic bomb.
Yeah.
Wow, that's a downer.
Yeah.
I remember him for his statistics.
Yeah, he's got Fermi-Dirac statistics, golden rule, beta decay. Sure, he did the neutrino, innit? God damn.
Yeah. So it seems like it's just crazy how, it starts by people saying, okay, let's try to understand the universe as accurately as possible. And obviously it started with philosophy, it's like, let's try just to understand the world around us. And it just feels so crazy to me that it's just now the sort of school of people trying to understand the universe is sort of reserved for the select few, like way less than 1% of people who are able to understand it, because that essentially doesn't mean much to me, from an untrained.
But that's it. It's from an untrained mind. I don't think there's anything. There's the only reason that you can't understand or feel as if you don't understand what we're saying is that we'd ideally have years to go through all of the developments that's happened. So I don't think there's nothing. I don't really see it as a intelligence problem, just as it's more of a the groundwork. Problem. And if you are really excited about it, you start laying the groundwork when you're a teenager, and you don't consciously do it, but you're just building up these ideas. And it's just, the longer we go, we've had to rush 100-year story here. And if you take any of those decades, you could talk for hours and hours about the developments that happened within that decade. And it's just it's such a compressed story that we have to present to talk about this one number and this one difference between two numbers. But do
you think it's the only way to understand the universe?
No, I mean, like, I think if you're trying to put food on your family's table, this is a waste of time, right? I don't have time to listen to this.
But even just from like, the point of view of just without, having to worry about what you have to do with your family at the table and making money and stuff like that.
My point just is go on.
From another point of view, right? I'm wondering if physics really, is the best and most sort of universal way of understanding the universe. Because for me, from my point of view, after this sort of conversation, it seems to me like just so ultra specific. You know what I mean? That I have to strain to try to really get what's going on, and that multiplied by the fact of how much that there still is to learn. Like, do you think it's realistic? Like, even though, I can see the value sort of, just constantly get better and better and learn more about the material universe, like, do you think it's realistic to say that in our lifetime that it is possible that we'll be able to understand everything?
What?
You go, Ewan.
But who, you mean like this group of people? I mean, in terms of like just telling this specific story to you, and it either hits home or it doesn't, right? I mean, you know, you try and think of like sports, right? I mean, say exercising is good for you, but the people who are, you know, pushing the sports to the limit, the 100-meter sprinters or marathon, whatever, I mean, that's extreme levels. But just having, and yeah, it'll be impossible to have everyone to have an appreciation of enough like scientific thought to maybe appreciate what this number is, right? Or what this whole measurement, this whole story that we've worked so hard to try and tell you, and sometimes it lands and sometimes it doesn't. It's a hard thing to do. But just a general appreciation for, like, I always go on about statistics or whatever, but just a mindset of measurement, you know, of appreciating what a number means and what an error bar means. I think that's extremely useful for everyone, no matter what. I mean, this coronavirus, more than ever, knowing what a fucking exponential is, or knowing what a result means, or the success of a you know, of a vaccine, or even like the problems with a vaccine. What, like when you fucking hear some terrible story of someone dying of blood clots, versus just questioning, all right, how many out of how many, and how many die of a coronavirus, you know? Just, and I'm not saying that's like I'm just saying that mindset to initially go to that for anything. What does something mean? You're telling me a number. What do I think about that number? What do you mean by that number? Seven plus minus one. I think that's good.
I'm not disputing that like the scientific method is good or anything, but
you can dispute that. I mean,
on the topic, I do think that the scientific method is good and useful and extraordinarily necessary, but I am not really of the opinion that it is a complete picture. You know what I mean? I don't think just following the scientific method offers you a complete picture. Like what I was going to say is that I think that there's sort of, from my perspective, I sort of feel like that there's a sort of easier way to, like for ordinary people, let's say, who don't study physics, to sort of feel like they understand the universe, not through an intellectual point of view, but through like meditation and Eastern philosophy and or psychedelic drugs, you know? Like I do, like it's just I guess like both of them are ways and sort of, you know, endeavors to try to understand the universe. But I think that physics is good, but it doesn't offer the same experiential understanding that you can, you know, get through other ways.
But yeah, I think it depends on the question you want to ask, or it depends what you want to learn. And you know, to sort of progress physics, we need to work on either smaller and smaller length scales and keep pushing it into probing those really small distances, or really weak interactions, or you know, go the complete other direction and study galactic structure, etc. Like to improve our knowledge in those directions, we are forced to take it away from the human experience. So, you know, even in the early 20th century, the ideas of quantum mechanics was a step away from what we experience and how our intuition of the world works, because we live on just a single distance scale. Like this is a human length scale. We don't live. The ranges of length scales that we experience are from maybe 0.5 millimeter to a few kilometers, maybe hundreds of kilometers. Like that's our length scale. That's the distances at which we live and experience. And what we're talking about with like either atomic physics or distances at the LHC, like distances within a proton, even the numbers are meaningless to say how far removed we are from those length scales. And we're at those length scales to learn about the most fundamental building blocks that we know everything is made of, and their interaction with each other. And from that, you can ultimately see how that's related to older theories or previous theories that didn't have access to those length scales. And they sort of, as you sort of squint at them, they and gloss over the distances, you get new, less accurate theories, or older theories generally. And it's just because particle physics and doing these, those loop diagrams and those squiggles is an accurate way of doing these really minute experiments, very detailed experiments, doesn't mean that particle physics is the best way to do chemistry, for example. We're doing that calculation there is a very specific process, whereas if you have a theory of chemistry, it's a much coarser theory that lives on a much larger distances. And it's a theory for a different scale of distances. And just like talking about things in terms of chemistry and chemical reactions is not a good way to describe how to bake a cake. I mean, it can help, but it's not a good way to sail a boat.
I guess
you should use the framework that's appropriate for the distance scales that you're working with. And if you want to think about how the human brain works, particle physics is no good. It's the wrong length scale to work at.
I guess that's sort of my point, not about physics, but sort of about science in general, is like, I guess my qualm is sort of more specifically directed at, say, psychology, where, it's so, this is sort of like back to my sort of qualm about the scientific method and how I don't really think it offers a complete picture. I suppose it's sort of directed specifically towards psychology. Is like, I feel like just using the scientific method to study the human mind, it doesn't offer a complete picture, because you're trying to put an objective framework on something that is inherently subjective. You know what I mean? And trying to basically reduce human behavior to like the level of the neurons, I was that towards the end of Viktor Franklin's book, he said something really, really cool that I really, really liked, because he was also a psychiatrist, like a professor of psychiatry also. So he said something about, like, I think he was talking about free will, and how, and basically how people reduce human behavior and human substance to the level of genetics, basically interacting with the environment and the social and cultural environment. And he said, I'm well aware of how fully, he said, as a psychiatrist and a neurologist, I'm well aware of how, or to the extent to which human beings' behavior is influenced by their genetic makeup with their environment. But he said, I'm also a survivor of 4 concentration camps. And he's like, so from this point of view, I'm, I feel that I have freedom, and I feel that how human beings are able to also transcend, the influences of their environment. Yeah, anyway.
Kudos for you for crossing over. I mean, we started this whole podcast when you describe yourself. You never really said it to us, but making a jump from, you weren't in psychology or whatever, you go and experience life, you're going living around all these places, which I thought was pretty cool, if we're going to go back to, in terms of being inspired by each other. But yeah, you've crossed over to both of them, and that's the whole thing. I'm certainly not under the illusion that physics is the absolute way. I'm pretty sure we discussed about it. Your shit smells like everyone else. Like, your shit's not the most important way of doing it, but it's the most stimulating to my fucking brain. And thank God there's people who are studying brains and seeing why they're different and why people act the way they do, right? And kudos to you for doing that. And then good for us for fucking having a fucking all three of us are talking. I mean, I interact with physicists on a day-to-day basis, and that's who I talk to. And sometimes I find that fucking crazy. We're all in these little bubbles.
I find that totally crazy, by the way.
I mean, it's not crazy as in you can see how it happens, but I just think, of course, people.
Yeah, but I feel that's so unhealthy. Like,
yeah, of course.
To just be surrounded by people who are of the
Agreed.
same inherent mindset as you. I mean, that's got to be bad for you, you know? Like,
and that's why I like arguing about you about fucking pretty
Yeah.
much everything that we have an opinion on.
well, I think it was like what I only kind of thought about it a few days ago. That I've always had like really, really strong opinions, you know, sort of about like mostly meditation, because like from a sort of personal subjective experience, I kind of have this fear. I had this feeling like everybody should fucking do this, because I basically cleared myself of, you know, many chronic mental pathologies, still some to go, but but I suppose it was really nice, I suppose, that through this sort of conversations, I realized, okay, well, there's some holes in my argument, perhaps, and maybe my arguments don't have as much sort of credibility as they could if I also understood, say, the intellectual side of things. And now, having tried science, I really, really like science, and I think that the scientific method should be applied wherever it's possible. But what I really don't like is this sort of idea, it's not falsifiable, so it just isn't worth the time. You know, because I'm looking at particularly, like if I think about Carl Jung, for example, his theory of the collective unconscious, you know, that we're all sort of inherently sharing an unconscious mind, you know, that's not falsifiable. But when you sort of look at his own argument and you sort of say certain people who have like a lot of synchronicities happening in their life, which is like a very, very real phenomenon. And if you sort of look at it in this sort of more subjective and sort of philosophical way, it makes total sense. But it's like people are just like, that's not a falsifiable theory, so it's not worth the time. I think, you know, to say it's not something isn't falsifiable is sort of, so that means it definitely doesn't exist. That's the sort of thing that I don't like about scientific.
I just think it just, if you begin to be open to non-falsifiable theories, you open the door to everything. And how can you?
That's not true.
But if there's something, two synchronicities that can be measured, then we can measure it and see if it's true or not. And if there's no way to measure it, then if it is measurable, let's measure it and see if it's right or wrong. And if it's not, it's as good as anyone's theory. And I think, you know, for me, I'm very critical of myself, and my ideas, and I hate being fooled or led into ideas that if I catch myself thinking something that actually wasn't true, or having a false memory, like all of these things, or thinking something because I wanted to believe it, or remembering something in a way because I wanted to remember it. Like I find I'm such an unreliable thinker in my mind, and I fool myself, and I'm good at convincing myself that things I want to be true are true, and I just try to the best of my ability to not be led down those paths and just stick to, you know.
Yeah, sure. I agree,
and we say that
that
it's true.
It definitely does open up a lot of danger for just believing in anything, let's say. But say that's if you're just contained within your own sort of isolated mind, right? But for sort of, okay, what I'm sort of specifically thinking about is the collective unconscious, and also, say, for example, the sort of phenomenon of enlightenment, you know, that you can meditate yourself into a state of total understanding, experiential understanding of the universe. And say also the idea that when people take psychedelic drugs, that there's something collective that people are sharing, that it isn't, that it can't necessarily just be reduced by a change in neurochemistry, because everybody, or like a lot of people who take psychedelic drugs, all report having some very profound spiritual experience. You can sort of see how these three things are kind of within the same realm, you know. And so in this sense, like you can't falsify that, because it's like an immaterial experience. It doesn't really have, you know, you can't really translate this sort of subjective experience to the material world, or into, you know, you just can't. There's no way to like verify, you know, somebody else's subjective experience. But to say that nothing is happening, I don't think so, because especially, okay, if it was just one person, but if you're hearing the same sort of accounts from, you know, hundreds of thousands of different people, I start to think like.
But what's the qualm? Your qualm is with someone, a scientist, who like scoffs at that.
Yeah, basically, yeah. Because for me, this is like this is like this sort of experience is equally, if not more, fundamental to understanding the universe, you know, because it is like when you have these experiences, say, of total enlightenment, it's like beyond words, really. I did hear a great poem that closely described it, but it's an immaterial experience that is beyond words, that suddenly gives meaning to existence, you know. From this is my personal experience, and also the experience of many other people I've talked to, you know. So for me, this is like a very important subject, you know, when it comes to understanding the world around us. And it's like, okay, if you can induce these states and suddenly you're in this feeling of enlightenment, where you understand the universe, and you understand a meaning in your life, and you feel this sort of connectedness with the rest of all of existence. And if we're able to harness that and sort of make people feel it, and have people understand it, that's really important. And, you know, for it to just be kind of reduced, being like, okay, this sounds like hocus pocus, you know, it's just this sort of attitude of the scientific community that I don't like. It's like, oh, that's hocus pocus, because people don't want to risk their careers by sort of endorsing anything that sounds remotely spiritual, you know. And that's why I don't like.
Well, okay,
Yeah,
that's a fair point. If you're talking about the community, right? I mean, well, to me, like if you're scoffing at it, when you started talking about that specific example, and I know you mean a general, you one that you can't measure or whatever, but I'm immediately start thinking about, can you measure, say, the number of people who have some kind of experience like this, and then can you see what their environment was, and are there enough of them that you can do that? Or even for a specific person, obviously some people talk bullshit, right? And it's natural for a scientist to discredit a single data point, you know. But the whole point is, my head immediately goes to, can you explain why that person might have had that experience, as you said, through some fucking brain shit, you know, through science. But yeah, of course, it's the whole point. I would agree too. If scientists immediately scoffs at it without thinking of these things, ways to explain it through their fucking viewpoint of the world, then yeah, it's a shit scientist. And the truth is, with like I think about it more and more. Everyone, like the number of people who call themselves a scientist, it's a big number of people, and not all of them are good. So
yeah, maybe. So like we're going back to like what me and you do, particle physics. I've okay, just from my own experience, or from my own what I value as cool or important or interesting, or you know, crucial to find out, that's different to what I feel like we can currently make progress with. So testing the standard model, okay, I think that's really cool, but I think it's a lot more valuable if we could figure out the hard problem of consciousness, or if we could learn more about consciousness. I think that'll be way more valuable and way more important, and I wish I could make progress on that. But I wouldn't even know where to begin. But I know I can make progress on, you know, the Large Hadron Collider is really stupidly simple. Like you're colliding stuff and seeing what they do. Like I sometimes wonder if we're just at such early stages of the scientific method, like we're just really getting started, that maybe there's a disparity between, placing science and internal meditation on an equal footing or comparing them. We could be just, it could take 1,000 years before the scientific method becomes valuable in understanding these deep things about consciousness. And maybe at the moment, looking internally and meditating might be the way to access some truths about yourself, or some things that you might know to be, you might feel to be true. And as the other thing that crossed my mind, or the other point was, I wouldn't deny that all of these meditators have had some common human experiences and perhaps felt as if they were connected to the universe. And I don't deny that that could be a state that the brain could feel. But I guess the point I'd become skeptical at is that, okay, even if we all meditate and get the subjective experience that we are connected deeply, to then make the claim that therefore we are connected deeply across distances. That's the point at which I become skeptical, but not denying the subjective experience of feeling those things.
Yeah, that's understandable.
Glad we sorted that one out.
But maybe it's just, maybe we're just,
But see, there's something objective about it too. For me, it's like, it is a subjective experience because I'm feeling it inside my head, for example. But what's objective about it is, it's like this, for me, it's like objective in the sense that it's the same sort of experience that has been described in a very good detail to be the same for thousands of years, since ancient Vedic, before the yogis, and for me that's quite a profound thing. And when it comes to being a human and the sort of understanding what is important about being human, and that's really important, for me. That's like, okay, if a human being is able to get into a stage where they feel like they totally understand everything, they become compassionate beings, and suddenly find a meaning in their life. And it's the same sort of experience that people have been reporting for thousands of years. I just don't like reducing it to be like, even if you can see what's happening in the brain, okay, something special just happened in the brain, it still doesn't, it's still a very dry sort of explanation.
Yeah.
So
I'd be lost without meditating as well. And even though I am a scientist, I maybe correlated with that is a tendency to have anxiety, to have imposter syndrome, to feel inadequate, berate myself for not solving my problems. And if without the techniques of meditation, it would just, I'd have a lot of additional suffering. So, even if your only goal is, to be a good scientist and to be a complete skeptic, I think if that is your only focus, and you deny the benefits that could come with meditation, or just any way of understanding yourself as a rational human being, perhaps, that is really helpful in having a life, and a good life. And as Iwan says, we're all about stimulating ourselves in various ways and having a good time. That's important. Like we just have one life in the end. Yeah.
Stimulation, bro.
I have to say, since I started studying, my anxiety level is just like increased a lot, and I'm trying to figure out why that is. And at first I thought, I was like, okay, it's just because you just spend less time meditating and doing yoga and like actively relaxing. But then even when I'm going to sleep, I find it sort of more difficult to turn off my brain. And I think I've sort of transferred over into being like somebody who's just like, just experience shit, but you know, just like really just wanting to be, say, mindful and yeah, accepting of the present moment, to being like not being able to stop analyzing everything. And I'm starting to wonder if I can live like this for much longer, to be honest.
Wait, which direction? Sorry.
Like
You were a witch and now you're a witch?
like I feel like my whole sort of life before was just about you know, getting richness from life out of experiencing stuff, you know, and just, you know, and since like studying science, I think I haven't, like, it's just been, my brain is just constantly just analyzing everything. And I think it's sort of induced sort of, you know, an acute you know, anxiety, acute and constant anxiety. And yeah, I'm wondering, is this the best way to live? You know, just
maybe
to
not.
constantly trying to
I've seen
analyze
that.
my environment.
No, I've seen that before. It's ruined like TV shows and movies for me. I just can't. I find it so hard. If I see a scene and something happens, I'm immediately off. Like, oh, that's why they put that scene there, or how did they shoot that? Oh, the camera there. And like, I fucking wish I'd stop doing that. And I can't fucking.
Yeah.
Oh, you put that. Oh, you made him real relatable before you killed him. Obviously, you know, like I just
Yeah.
I can't. And then I'm never upset when someone dies. You know, like, oh yeah, well obviously they. Yeah, that's why it's just fucking, it's the worst. So maybe
Yeah.
it isn't the best way to go. But
Yeah.
turning off, I mean, I have the best advice I have gotten is to try treat this, even though it's what you think and it's your way of looking at life. It's a job. What I'm doing right now is a job. And so it's really hard. But if you want to be healthy and be able to sleep at night, know that when you close your laptop, that's it, you know. But it's fucking hard.
Yeah.
Maybe that makes me a worse physicist, but it makes me
Yeah.
happier. So
The laptop thing is sort of getting, like, I'm really starting to notice just how much time I spend on my computer.
oh, my eyesight's gotten worse.
Oh yeah, because also even when I finish working, my leisure time is also like laptop related.
Mhm.
I'm like, oh, I'm gonna go read the news or like watch some YouTube videos, but I realize if you're just looking at it from an external perspective, it's just me sitting like at a computer, or else I might go from sitting to like lying down in bed. But it's crazy just to think how that happened. Like I never noticed the transition of just okay, now I'm just always on my fucking computer.
Yeah.
I don't
It's
know if I
fucking,
can
it's
live
bad.
like
And I
this.
worry about that shit as well.
Yeah.
We've chosen this fucking
Yeah.
way forward. And I'm like, the one thing keeping me is honestly, is like running. Like, I don't even do it that much, but you can't, I find it hard to replace that time when you're just in your head and you've got nowhere to go because you've set this path and you're just in your fucking head. And that's the best. That's the reason I go running now, just for that.
Yeah.
Horrible.
But are you two sort of happy to accept that this is just it's now for the rest of your life? Is like your most of your waking hours are going to be spent on a computer? Are you happy with that? Are you willing to accept this?
I'm gonna do it for a few more years and see, because the game changes, and I don't know how I'll feel. You know, at the moment I'm single and I'm also in a pandemic with no ability to have hobbies, so it does feel like a greater part of my life than it did a few years ago. And I'm, you know, if I want to start a family, my perspective will change completely. So it's hard to, you know, project myself forward into the future and imagine what I will want to do. But I would like to, if I can, get a job doing this for another few years. I would like to, but you know, there's loads of ways to live a life, and it might be a shame to just spend an entire life doing this one thing.
Yeah.
I mean, you feel it more like I'm in the transition stage right now, thinking where I want to go next. And you know, right now there's options to go to America or go to China, and both of those are mad to me. Well, not they're not mad to me, but I mean, I'll like whatever. We don't have to start talking about American China, but I'm saying I'm not gonna lie. Like my brain, what's deciding me or making me decide is just which is the wackiest one, which will mix things up the most. And in terms of not knowing what the future is, throwing yourself into the wackiest one, sometimes it kind of appeals to me as in like mix up your point of view and see where it takes you. Because I can't plan if World War III is going to happen, you know, if like or you're going to go to jail for either saying something against the Chinese government or saying something about gay rights or something. Each one sounds scary to me, you know, like so throw yourself in the wackiest one, because who fucking knows whether you want to do this for the rest? How the fuck do you know? I don't fucking
Yeah, but just I'm starting to get like, even just from like a physical standpoint, I'm just starting to get terrified of the fact that life is going sort of in a trajectory like the only way to make money is to sit at a computer like this all day. It's just like, honestly, really, fuck, you know.
Yeah, honestly. I mean, I always look at sports people. I'm like, you fucking break your thumb and then you can't do your job. Oh, thank God I'm working on a laptop. But then you're like, oh, I wish I was, you know, wasn't just fucking working on a laptop.
Just like having so much back trouble. And like, do you guys have back problems? Like,
and everyone I know has
shoulders and shit. Is this just what life is gonna be now? You know?
Yeah. You make me want to go outside now. This is fucking,
me too.
I realize we've been sitting here for 2 hours. And
how long has it been? It was anybody
like a little after 1, right?
Yeah, we started chatting about 1 o'clock.
Well, we call it. This is our good first try run. I mean, this is I enjoyed it. That was good.
I had fun.
I think we jumped a little bit all over the place at the beginning, and and then maybe the detail of the muon thing kind of lost me for a while, but I think it's a good one to look back on.
I hope the hundreds and thousands of fans enjoyed it. And, please comment below about what you want us to talk about next.
Now you'll have to flash up me and Iwan's Insta handles. You know, a bit of self-promotion. What book I'm writing, what book he's writing.